Hi, welcome to the video solution for Edexcel past paper. This is Edexcel Physics, Unit 1, January 2021. So let's start. Question number 1. A car is moving towards a stop sign at the speed of 25 meters per second. The driver applies the brake 20 meters before the sign and decelerates uniformly to rest just before the sign. Which of the following gives magnitude of the car's deceleration in ms-2? So you have a sign here, and the car is moving. This is the car moving at that moment at a speed of 25 ms-1. And the driver applies brake, and that distance is 20 meters, and the car starts decelerating uniformly and comes to rest just before the sign. So here the car just stop, and you need to find the magnitude of deceleration. So you have initial velocity and final velocity will be 0, and this is the distance given s. So of course you can find acceleration using equation 2as is equal to v square minus u square. So acceleration is v square minus u square over 2s. So v square is 0 square minus 25 initial velocity square divided by 2 into distance, which is 20. If you simplify, you don't need to simplify because they are not giving you a simplified form, they are giving you expression. So clearly if you just ignore 0, so you have minus 25 square over 40. Of course, because you need to find magnitude, there is nothing to do with the direction, so you can ignore this negative sign. So if you ignore, that means your option is C. Question number 2. An object of mass 8.2 kg initially at rest falls a vertical distance of 25 meters through the air and has a final velocity of 20 meters second inverse. Which of the following gives the energy in joules dissipated by the air resistance? So you know that if you have object at some height, mass m, so and this is the ground, so at that moment the object has only energy, which is a gravitational potential energy, mgh, and as object starts falling down, gravitational potential energy is decreased and kinetic energy is increased. Ideally, loss in GPE equals gain in kinetic energy, but here object is falling through air, so some energy is dissipated. So if the object has fallen till 25 meters, so this height that the object has fallen is 25 meters, that means some gravitational potential energy has decreased and some kinetic energy has increased, and the difference between these two it will be the loss of energy. That means at that moment mgh minus kinetic energy, this difference gives us energy dissipated due to air resistance. So if you see mgh, so m is 8.2 into 9.81 into height fallen, which is 25, minus kinetic energy, which is half mv square. And if you see in the option, they are not giving you half. Instead of half, they are giving you 0.5. So half mv square, we can write half as 0.5 mv square. So m is 8.2 and v square is velocity is 20, so 20 square. So this is the difference that which is equal to the energy dissipated. And if you compare, so 8.2, 9.8 and then 25, yeah, option is c. Question number 3, the graph shows how the acceleration a of an object varies with time t. This is the acceleration time graph given, and we need to choose which of the following graphs shows how velocity v of the object varies with time for the same object. So clearly, if you see the graph, the given graph, so acceleration is continuously increasing. So whatever the acceleration is, continuously acceleration is increasing, but with decreasing rate. Remember, acceleration is increasing, but decreasing rate. So velocity of the object must be increasing because we have acceleration increasing. So velocity must be increasing. That means we cannot have option A because velocity is decreasing. It cannot possible. And we cannot have option C. Immediately you ignore A and C. The reason for C is velocity is increasing, but at constant rate. Acceleration for that graph must be constant. And we know that in our acceleration is not constant, acceleration is increasing constant for C. So A and C cannot be our option. And in B, velocity is increasing, and option C, velocity is also increasing. But remember, because acceleration is increasing, so velocity should keeps increasing and increasing and increasing, while in B, velocity is increasing but with decreasing rate. Here, acceleration is continuously increasing. So increase in velocity will be greater in every interval. So here, if you see, the velocity is continuously increasing with greater rate, which shows that the acceleration is increasing. So velocity increasing, v is increasing, acceleration is increasing. Here in part B, velocity is increasing indeed, but acceleration is decreasing with time. So option must be D. And I hope that you, if you can understand this, and I am planning to make some additional lecture of different topics. Let's see if I can get time. Question number 4. A student measures the time t taken for a ball bearing to fall at different measured distances as from rest. The student uses his measurement to plot a graph with a gradient equal to the acceleration due to gravity. Which row of the table shows a graph with the gradient equal to g? A ball bearing is fall at a different measured distance s. The student used measurement to plot the graph of, and gradient must be equal to g. So of course, if you drop some ball bearing, so generally we use a concept of equation s is equal to ut plus half at square, and because it is dropped, so u is taken as 0, so s is equal to half a t squared. And if you make a as a subject, which is acceleration, so acceleration would be equal to 2s divided by t square. Clearly, if you see, if you can plot graph of 2s on the y-axis and t square on the x-axis, then you can expect a straight line passing through region as per this relation, because acceleration due to gravity is constant. And of course, if you find the gradient of this line, rise over run, so gradient would be equal to y values, meaning rise, which is of course 2s, divided by run, and run will be t square value. So gradient would be equal to 2s upon t square. So you should plot graph 2s on the y-axis and t square on the x-axis. So on the y-axis you should take 2s, and okay, x-axis you should take t square. So option should be B. Question number 5. A student is investigating a material in the form of wire. Which of the following properties of the wire will change if a longer wire is used? Breaking stress, density, stiffness, and Young modulus. Remember, if you change the dimension of the wire, size of the wire, especially length, then when we talk about tensile forces, if you change the length, the only quantity is affected by changing length is the stiffness, because breaking stress is constant. Wire always break at given wire breaks at some constant force all the time. Density is the property of the material, not the property of the sample. Similarly, Young modulus is also the property of material, not the sample. Now, what does this mean? If you have two wires of different length, this is the wire 1 of length L1, you have another wire of length L2. So for both the wire, because lengths are different, so breaking stress will be same for both. Density, of course, it will be same, because it depends on what type of matter, what type of material, or which material, from which material these wires are made of. Similarly, Young modulus for both the wires will be same. But if you find the stiffness for both the wire, then stiffness will be different. So stiffness is the one which is affected by the dimension or the size. So option is C. Question number 6. Two objects are traveling directly towards each other and then collide. Object A is a mass 2 kg initially traveling to the right at 3 meters per second. Object B is a mass of 5 kg initially traveling at 2 to the left. What is the total momentum of A and B after the collision? So you can visualize the total momentum by drawing the diagram. So you have mass A. This is A, 2 kg, and traveling right at 3 meters per second. So, and another object B, which is 5 kg, traveling left at the speed of 2 meters per second, or 2 ms minus 1. So the total momentum will be sum of the individual momentum. So if you find PA will be 2 times 3, which is 6 Newton second, or kg ms minus 1. I'm not writing unit because there's nothing to do with that. And B has a momentum 5 times 2, 10 PB, 10 kg ms minus 1. And because momentum is a vector quantity, so clearly if you find one is left and then the one is right, so of course you can choose any one as a positive momentum and the negative momentum. So clearly the resultant will be 10 minus 6. 10 minus 6, which is 4. This is the total momentum of these two objects or of the system. 10 is greater, so it will be towards left. So 4 kg meter per second to the left. Option is A. Question number 7. A student determines the terminal velocity of a ball bearing as it falls through oil. He releases the ball bearing at a point V here and measure the time taken for it to fall a measured distance. Remember, it's all about terminal velocity. Terminal velocity means there should be no resultant force. There should be no acceleration in the motion. Which 2 points should be used, or should he use for the measured distance? Vy, Vy cannot be our option because as the object is dropped in this interval, object will be accelerating. So V cannot be involved. W and Y, of course, W you also cannot apply because the ball bearing just started experiencing drag force but is still accelerating. So W cannot be your option. X and Y. Yes, X and Y is your the best option in this case because after W, drag starts increasing, and it is possible that at X, drag balances by the other forces. So at that moment, all the forces are balanced. So X and Y are the possible and the best option to measure the time taken. So X and Y are option. W and Z, again, I have already told you that W cannot be included for to measure the distance for terminal velocity. We can use X and Z, but X and Z are not given in the option. That's why we have option only X and Y to choose. Option is C. Question number 8, which of the following is a vector quantity? If you have a list of scalar and vector quantity, clearly density is a scalar, kinetic energy, all types of energies are scalar. Viscosity is a scalar, only momentum is a vector quantity. Option C. Which of the following statement is not correct for Newton's third law, pair of forces? Again, I have a plan of making videos of explaining Newton's laws in detail. I am planning. Let's see if I get time as soon as possible. So now the Newton's third law pair of forces, there are some properties for the forces to be a pair of forces, or Newton's third law pair of forces, and these pairs of forces or these properties are these. And so the forces should have a if you can say if forces have a same magnitude and the forces are of same type, then these two are called similarity. So forces should be similar in these two ways. They should have the same magnitude, or they should be of same types of forces. And the forces must act in opposite direction, and the forces must act on different object. Okay. If I'm able to make some video, then I will give you the complete detail of these differences. So the first 2 points are called similarity. The next 2 points are called differences between the Newton's third law pair. So they are saying which of the following statement is not correct. So the forces act in opposite direction. Indeed, this is the valid point. So it is not correct. Meaning it is correct, but it is not the option. We need to find not correct statement. The forces act on the same body. No, the Newton third law pair of forces should act on different object. So option must be B, because it is not correct for Newton third law of pair, and rest are okay. So option is B. Question number 9, a locomotive pulls a train at constant speed against a force of 84,000 Newton. The output power of the locomotive is 70 million watt. Which of the following gives time in second for locomotive to pulse the train at a distance of 1 kilometer? Okay, there are many ideas that you can find the option, but in my opinion, the best option is, because we are given power and we are given force. So we know that power is force into speed or velocity, F into V. This is another formula for power. So F is fine because force is given. Velocity we can use distance upon time. This is a simple formula. Velocity or speed is distance divided by time, so S upon T. So you can put force into distance divided by time. If you see, there is some situation where the number does not look same as given, but the 8400, as if you see, yeah, okay, 8400, which is the force, you can write as 8.4 and 1000 and this. So you can write 10 to the power 6 because this is kilo 10 to the power 3 and you have a you have shifted 3 places. You have shifted decimal for 3 digits. So 10 to the power 6. So this is the force. And 70 megawatt or million watt you can write as 7 into 10 to the power, this is 1,000,006 and 107 watt. And the distance is 1 kilometer, which is you can write as 1000 meter, or 1000 meter, or 10 to the power 3 meter. So you need to find which of the following gives time. So make t as a subject. So t would be equal to Fs upon P. So force is 8.4 into 10 to the power 6 times distance, which is 1000 meter, or 10 to the power 3 divided by power, and power is 7 into 10 to the power 7. Indeed, option is C. Question number 11. A uniform plank of length 4 meter is pivoted 0.9 meter from one end. The weight of the plank is 250 Newton. A person of weight 950 Newton stands at one end of the plank. A person of weight 650 Newton stands at a distance x from the pivot so that the plank is in equilibrium as shown. Add to the diagram to show the forces acting on the plank. 2 marks for question, acting forces. So clearly if you see there should be 4 forces acting. Number 1 is weight of that person. You can draw this one, which is 950 Newton. You don't need to write number, but this is the one force. Another force acting by that person, which is weight of the second person, 650. And then you can have a weight, of course. There is a weight of the plank, 250. So this is 4 meter. And it is a uniform rod. So weight will be acting at the center. So around the center of this plank, I guess, should be somewhere here. Your choice, you can draw weight. So this is 250. Again, I'm saying you don't need to mark the value. Arrows are important, the correct arrows. And of course, you have placed the plank on some pivot. So pivot is applying a reaction force in upward direction, and reaction force should be greater because this is sum of all the forces. So these are the 4 forces that you should draw in order to get this 2 marks. So that's how you can see. These are the 2 forces. Now calculate the distance x. Okay, so it is a typical question of moment because we know that it is in equilibrium and we have a pivot. So we have moments, clockwise and anti-clockwise moment. And if you see, this is the pivot, and one force is acting on the left side of the pivot and 2 forces acting on the right side. And with reference to pivot, this is the 950 Newton force, and this is 650, this is 250 Newton force. So 950 Newton is trying to produce moment in anti-clockwise direction. So we have anti-clockwise moment, and then 650 Newton is going trying to produce moment which should be clockwise. So this is clockwise, and 250 also producing clockwise moment. Clockwise. So we have 2 clockwise moment and 1 anti-clockwise moment. Let's equate clockwise moment is equal to anti-clockwise moment, or sum of clockwise moment equal to sum of anti-clockwise moment. We have 1 anti-clock and 2 clockwise moment. So you can say that 650 times pivot distance. Pivot distance for 650 is x. That's what we need to find. Plus another clockwise moment is 250 times pivot distance. So 250 times the pivot distance, and we need, this is the force, we need that distance, remember. So we know that the plank is 4 meter long, and this is the weight. So that distance is 2 meter, half of the rod, 2 meter. And this is 0.9. So this is 2 minus 0.9, which is 1.1 meter. So 1.1 meter is equal to anti-clockwise moment 950 times 0.9. Now you just simplify these two, and then you can make x as a subject. So if you can make x as a subject, so you can find x is equal to 855 minus 275 divided by 650, and then x would be equal to 0.892 meter, or you can round it off 0.89 meter. This is the distance where the second person should stand in order to balance the plank. Question number 12. Moving walkway are often found in airport. On moving walkway carries one moving walkway carries passenger up on incline 30 degree as shown. A single passenger of mass 72 kg stands on the walkway. The speed of the walkway is 0.51. Show that rate at which walkway does work on the passenger is about 200 watt. So you need to find rate of work. So rate of work is basically power. So you need to find power. Again, if you use the similar concept, the typical concept of power is work upon time, or you can say energy upon time, because time is not given, so we cannot do that. But again, because the speed is given 0.5 ms minus 1, and the walkway is going upward, so basically force acting on the passenger is the weight. So we can use P is equal to force into V. But here is the key point about force. Remember, this is inclined plane situation. On inclined plane, if you put an object or a person, weight acting vertically down, and we have a two component of the weight. One is perpendicular, which is this. This is W cos theta, acting perpendicularly to the plane, and it does not do anything when the object is moving. It is just balanced by the reaction force. And another component of force or component of weight on the inclined plane always acts down the plane. This is another component, which is W sine theta. And remember, whenever you deal with the inclined plane, then W sine theta is the key force. So you want to find the work done, you want to find the energy or gravitational potential energy. This is the component of the weight or force, gravitational force, against which object moves. So basically this force is just not a gravitational force or weight, but this is component of the weight. So P is equal to force, which is W sine theta, and W is mg. So you can say W sine theta into V, and W is mg sine of theta into V, and m is 72 9.81 sine of 30 degree into V. V is 0.51, and the power or the rate of work will be 180.1 watt, which is approximately 200. This is the power or the rate of work done by the walkway on one person. The walkway system has an efficiency of 78%. Calculate the power input to the system when 15 passengers of average mass 72 kg are standing on the walkway. So you need to find input power. Efficiency is given. Again, I guess you have now you have an idea. Efficiency is given. So efficiency is output power divided by input power. That's what we need to find. And output power is efficiency is 78. So 0.78 is equal to output power. We have a output power of a walkway for one person. So 180 times we have total of 15%. 15 persons or passengers are there. 15 divided by pi. Now you can make pi as a subject, and if you make pi as a subject, so pi or input power will be 3463.5. That means 3.46 into 3 watt, or you can say 3.46 kilowatt. That's how you can find it. Question number 13. A rugby player kicks a ball off the ground at an angle of 35 to the horizontal as shown. The ball reaches a maximum height of 5 meters before returning to the ground. Show that initial speed of the ball is about 17 meters per second. So the idea is, because we have given the maximum height 5 meters, so you know that at maximum height the vertical component Vy is always 0, and that's what we can use. So we can use the equation 2as is equal to v square minus u square, and v is the final vertical velocity and u is initial vertical velocity. So you can say yes, 2 into minus 9.81. Why am I using minus? Because the ball is going upward, because we are considering vertically upward motion. That's why I'm using minus 9.81. And this s is a vertical height, which is 5, is equal to v square is the final vertical velocity, which is 0, minus initial vertical velocity, which is u square sine square 35. Because remember, the initial vertical velocity uy is u sine theta. So now you have everything. You can make u as a subject. If you make u square as a subject, and if you calculate u, then u will be equal to 298.2. Check yourself. And then when you take the square root, so u would be equal to 17.26 ms minus 1. This is the initial velocity of the ball. After traveling a horizontal distance of 22 meters, the ball reaches the goal. To score, the ball must be more than 3 meters above the ground when it reaches the goal. Deduce whether an initial speed of 17 is sufficient to score or not. Okay, it is again a typical question of projectile. They have given us a vertical height. So basically, what do we need to do? This is suppose the position where the ball is hit and the ball is going. Now the idea is we need to figure out how high, if you kick the ball at 17 meter. So you are kicking ball, or the player is kicking ball at that speed. So you need to find, if you kick the ball at that speed, how high the ball will go. So you need to figure out how high the ball will go if you kick the ball at 17. And once you figure out this h value, and this, remember, this is 22 meter away as per given condition. So you need to figure out how high the ball will go. And if this h is equal to or less than 3, then of course there will be no goal. But if this h is greater than 3, then there will be a score, or there will be goal. That's what we need to do. So of course, if we need to find the vertical height, we can use h is equal to ut plus half at square. But the problem is we do not have time. And that's why they give you horizontal distance. So using horizontal distance, we can find time, t, and use that time in this equation to figure out h and then compare. That's what we are doing. So let's first we find the time. And in order to find time, we're going to use a horizontal motion. So s is equal to ux, which is horizontal velocity, into t. So s is the horizontal distance, which is 22. And this ux is u cos theta, if you remember. So the angle was 35. So u cos theta into t, and 22 is equal to u we have found, which is, or not found, they are saying that we need to check 17. So 17 cos of 35 into t. And if you make t as a subject, then t would be equal to 1.58 second. This is the time when the ball reaches to the goal. Now let's use h is equal to ut plus half at square. Remember, this u is not the velocity, this is vertical velocity. So h is equal to u is u sine theta. Remember, this u is u sine theta. So h is equal to 17 sine 35 into t, which is the time, 1.58. Ball is going upward, minus half, or 0.5, into minus 9.81 into t square, 1.58 square. Now use your calculator, put all these numbers in one go. So h will be 3.16, which is approximately 3.2. So of course 3.2 is greater than 3. So yes, there will be score. I hope that you've got the idea. And I'm sorry about my writing, I'm just trying to improve. Question number 14. A photograph shows a fireboat used to put out fire on ships at sea. The pump fixed to the boat pumps water from the sea. Okay. The seawater is projected at high speed out of a pipe connected to the pump. The mass of seawater pumped each second is 300 kg. It is really key information. Mass per second, remember, each second. So this is just not a mass, remember, it's not a mass. This is m upon t, mass per second, which is the value is 300 kg second minus 1. Okay, the pipe has a diameter of 10 centimeter. This is D. Density of the seawater is 1030. This is rho. Show that the speed of which the seawater is projected from the pipe is about 37. You need to find a speed V. Okay, now the idea, this is again a typical question. I have seen many such question of such type. Now imagine you have a pipe in which water is flowing. So imagine this is the length and this is the area, and water is flowing in that pipe and coming out. So now watch what I'm doing. These working you do not need to show this, it is not required, but concept because you need to find a speed, and how do we get the formula for a speed in this scenario. So watch carefully. You know that m upon t equals, this m is the mass, and mass you can write as density times volume upon t, because mass is equal to density into volume. Density is mass divided by volume, so m is equal to rho into v. Now density as it is, this is v. V is the volume, and volume you can write as length into area. Watch carefully. This is a cylindrical pipe, so length multiplied by area gives you volume. So length multiplied by area gives you volume divided by t. And now watch carefully what is happening. Density, length over time. This length is the length of the pipe, but in fact this length is the distance traveled by the water or whatever inside the pipe is. So this length is basically distance covered by water inside the pipe. So L upon T is the speed. So density into speed into area, M upon T. Now you need to find speed. So V, remember I'm just changing. This is V, which is volume, and this should make a curl V so that you can understand the difference. This is a small v, or you can change the symbol, but this V is the speed. So make V or speed as a subject. So V is equal to M upon T into 1 upon rho into area. All these working, it is not required to show. If you already have a concept, you can start your working from here at this step, but it's your choice. Now, so V is equal to M upon T, which is 300, divided by density 1030 into area, and area is area of cross section, which is pi r square. R is the radius, this is diameter, radius is half, r is equal to d upon 2, which is 5 centimeter. But here we are using SI system, so this 5 should be converted, centimeter must be converted into meter. So 0.05 divided by 100, 5 divided by 100 in meter, so 0.05 is square. I forgot pi, so you can write pi here. So density time area pi r square. Once you solve that, so V would be equal to 37.1 meter. Second inverse. This is the velocity. Determine the rate at which the momentum of the seawater is changed by the pump. You may assume that seawater is initially stationary. So rate at which the momentum is changed. Okay, so you know the change in momentum is basically force. So rate of change of momentum. So rate of change of momentum is equal to final momentum minus initial momentum divided by time. Clearly, final momentum you can find just mass multiplied by speed, and you know that mass was in 1 second 300, speed was 37.1, minus initial momentum, because initially it's stationary, it is 0, divided by time, which is 1 second. And if you solve all these things, so you have answer which is equal to 11130 kg ms minus 2. Okay. Projecting water from the pipe causes a force to be exerted on the pump. Projecting water from the pipe causing forces exerted on the pump. Explain the direction of the force on the pump. Of course, this is the typical question of Newton's third law. Object 1 applies force on object 2, then according to Newton's third law, object 2 applies equal and opposite force on the object 1. So action and reaction force. Initially, the pump is turned off and the fireboat moves forward through the water at constant speed. Okay. The boat engine provides a constant forward force. When the pump is turned on, water is projected forward and fireboat slows to a lower constant speed. Explain why the boat now has a lower constant speed. Your answer should refer to all horizontal forces on the boat. Okay. So first you try to understand the whole scenario. This is the boat. So the boat is experiencing forward engine force. So let's call it Fe. And then there is a drag force, D, initially, before starting the pump. They are saying that initially the boat is moving at constant speed. That means the horizontal engine force Fe and the drag force are balanced and they are cancelling. So no resultant force, that's why no acceleration. So the boat has some constant speed and it is moving forward in that direction. Now the pump is on. When the pump is on, in previous part we have seen that the boat experiencing a backward force. Then this backward force causing a net resultant force in backward direction. So there is a net resultant force in backward direction. So the boat starts to decelerate initially. So the speed starts decreasing. Now, as soon as the speed decreases, the drag also decreases, because drag, remember, depends on speed. Okay, speed increases, drag increases. Speed decreases, drag also decreases. So drag depends on speed. So drag also decreased. So of course there is a backward force on the pump, but drag is also decreased. So overall, again, all the forces are balanced, and then the boat starts moving again with a constant velocity, but that constant velocity will be lower than the previous one. I hope that you will be okay with this explanation. Question 15. In a bungee jump, the bungee jumper falls from a high platform while attached to an elastic cord. The cord is also attached to the platform. The cord slows the bungee jumper down so that he comes to rest before reaching the ground. The fall can be divided into 3 stages. Stage 1, the jumper is in free fall until the cord starts to stretch. Okay. Stage 2, the cord is stretching until the acceleration of the jumper decreases to 0. So here we have acceleration to 0. Here we have acceleration is equal to g. And then the cord continues to stretch until jumper is momentarily at rest. Here we have acceleration negative. Explain in terms of work done how kinetic energy of the bungee jumper changes during the 3 stage of the fall. Okay, so we know that in stage number 1, the bungee jumper is falling freely, ignoring your resistance. So the only force acting on the jumper is the weight. And due to weight, the bungee jumper is accelerating. So basically gravitational force or weight of the jumper is doing work on the jumper. So kinetic energy is continuously increased because we have acceleration 9.81. So work done by the gravitational force, kinetic energy increases. In stage number 2, see what happened here. At that moment, and after that, in stage number 2, what is happening somewhere here, you can think like this. So the cord starts stretching. Now the weight starts acting down, but there is an additional force starts acting in upward direction, which is elastic restoring force. And now the resultant force is less than weight. But still weight is greater than elastic restoring force. So bungee jumper keep accelerating. That means speed keep increasing, kinetic energy keep increasing, but with decreasing rate. Continuously elastic restore, because the cord is continuously stretching. So elastic restoring force is continuously increasing and increasing and increasing. Velocity is still increasing, but with decreasing rate. So kinetic energy increases. At that moment, start of 3 stage, the elastic restoring force F and the weight are equal, balance. No resultant force, so acceleration at that moment is 0. But after that, the cord keeps stretching. So elastic restoring force now increase or greater than weight. So we have a resultant force now in upward direction. So the jumper, instead of increasing speed, now the jumper experiences deceleration. So speed starts decreasing in stage 3 until at the end of stage 3, where the kinetic energy is becoming 0. So that's how you can explain all the 3 stages. See if you're okay. You can manipulate your answer as per your understanding. This is not some standard, but it's your choice. And I would recommend you must try to manipulate, try to rephrase these answers. Thank you very much. I hope that you enjoyed the video. I'm just trying to make the second part of this video as soon as possible. Please visit this website. I will give this link in the description. You can find a topic-wise worksheet, and I have already made some summary notes, so you can find all your required. I hope that it will give you some benefit. Thank you very much. Have a nice time. See you in part 2.